Yeah, hello.
Hello, Ramit. How are you?
I'm fine, thank you. How are you?
Okay. Am I clearly audible to you?
Yep, everything is fine.
Okay. So, okay, my dear, in the previous session, I have discussed about thermodynamic equilibrium. Okay.
Yep.
Now, in this session, I will start from pure substance, and after that, we will study about property of system. Okay.
Okay.
Okay. So let's start, my dear.
Yep.
Okay. So, see, my dear, pure substance. What is pure substance basically? For example, you you say, sir, air is a pure substance. Why? Why any substance is a pure substance? Or under what circumstances a substance is said to be pure substance? Okay. So now,
Yep.
my dear, please understand this. If any substance has same chemical composition throughout and same chemical bonding everywhere, then that substance is called pure substance.
Yep.
Okay. I will simply take an example. Air. Air. In your room, air is present, and in my room also air is present. But my dear, for this air, chemical composition is constant. Chemical composition is same. At here and at your place, chemical composition will be same. Chemical composition means, my dear, you know that in the air, hydrogen, oxygen, nitrogen, okay, these gases are present in the air, and you simply know the percentage of O2 and N2 in atmospheric
Yep.
air by mass or by volume wise. Okay. So at your place, my dear, the composition of these substances, at your place is same as in my place. Okay.
Okay.
So Air, the chemical composition of air is same everywhere. Everywhere, my dear, everywhere in the world, the chemical composition of air is same. Now we will discuss about chemical bonding. Here a term is written, chemical aggregation. Aggregation means simply bonding. Chemical bonding. Chemical bonding should also be uniform for that substance. What is chemical bonding, my dear? What is chemical bonding? Here in this air, you can call, sir, here O2 is bonded with N2. Simply you can call O2 is bonded with N2. And everywhere in the atmospheric air, O2 is bonded with N2. And some inert gas is also present, as you know that. Okay. So chemical bonding should also be same. For that substance, you simply call that substance a pure substance. So air is our pure substance. So this is your simple example. Now I will discuss pure substance by varieties of examples. Simply you understand that any substance is said to be pure substance if it is homogeneous in chemical composition. Homogeneous means uniform.
Yeah.
And homogeneous in chemical bonding. That means chemical bonding and chemical composition should be uniform for that substance. Then we call that substance a pure substance. Now consider a container. Consider a container, my dear. I will simply take 3 examples so you can easily understand the concept of pure substance. I will simply take 3 containers. This is your second container. And this is your third container, my dear. Now suppose in your first container, suppose here water is present and above the water steam is present. You know that steam is lighter than water, so steam is above the water. Okay.
Yeah.
Now in the second container, we simply assume in the first part water is present, and suppose in the second part H2 plus O is present. H2 plus O is present. Okay. And in the third container, let us assume in the first part water is present, and in the second part H2 plus O2 is present. Now we have to tell about this substance is pure substance or not. Okay, I have to tell which substance in this container is a pure substance. Okay. Now my dear, for the pure substance, 2 conditions must be satisfied. First condition is chemical composition should be uniform, and second condition is chemical bonding should be uniform. So let's check here in the 3 container. In the first container, my dear, water and steam is present. And you know that the formula for water is H2O. And for steam also formula will be H2O. Okay. Okay, my dear. Now my dear, here the chemical composition for water. I will simply write chemical composition as CC. The chemical composition of water is 2:1. 2:1. That means H2O means 2:1. Okay. And for steam, also the chemical composition is 2:1. So you can tell, sir, here chemical composition is the same everywhere. Everywhere chemical composition is same. Okay, my dear.
Yep.
Now we have to check about chemical bonding. We have to check about chemical bonding. If chemical bonding is uniform, then that means both two conditions are satisfied. Then we simply call this substance as a pure substance. Okay. In the water, you simply call, sir, here two atoms of hydrogen is bonded with one atom of oxygen. Here in the water, my dear, two atoms of hydrogen is bonded with one atom of oxygen. And in the steam, the formula is also H2O, and here also two atoms of hydrogen is bonded with one atom of oxygen. So
Yep.
here, my dear, chemical bonding is also same. Bonding, okay? In the water and steam, two atoms of hydrogen is bonded with one atom of oxygen. So chemical bonding is same everywhere in this container. So my dear, our both two conditions are satisfied. So we can simply call the substance present in container 1 as pure substance. So the substance present in your container 1 is your pure substance. Okay. For this first container, my dear, for the first figure, chemical composition is same and chemical bonding CB is also same. So this is your pure substance. This is your pure substance. Okay. Okay. Now move to the second container. Now move to the second container, my dear. In the second container, here water and H2 plus O is present. So the chemical formula for water is H2O. So you can call, sir, the chemical composition for water is 2:1.
Yep.
And for here H2 plus O, here H2 plus O is present. So here chemical composition is also 2:1.
Yep.
Here chemical composition is also 2:1. Okay. Here the first condition satisfies. But now move to the second condition. Both two conditions must be satisfied. If one condition is satisfied and second condition is not satisfied, then do not call that substance as a pure substance. Now move to the second condition. In the second condition, we have to check chemical bonding. For water, my dear, here two atoms of hydrogen is bonded with one atom of oxygen. Okay. But in the second part where H2 plus O is present, in the second part, my dear, is it a chemical bonding? No, my dear.
No.
It is not in a chemical bonding. Here it is written that H2 plus O. This means this is not chemically bonded. This is a mixture. H2 plus O means this is a mixture. Here it is not chemically bonded. Here please cannot say it as a chemical bonded. It is not chemically bonded. It is simply a mixture. It is not chemically bonded. Not chemically bonded. Why this is not chemically bonded? Because H2 is mixed with O.
It's a mixture, yeah.
Then then here it is written that H2 plus O. So this means, my dear, it is a mixture.
Yep.
It is a mixture. So here second condition is not satisfied. Here chemical bonding is not uniform, everywhere. So our second condition is not satisfied. So I will not call this substance as a pure substance. So in the second container, my dear, in the second container, our first condition, chemical composition is same everywhere, but chemical bonding is not same everywhere. So this substance is not a pure substance. Not a pure substance. Okay. So this is not a pure substance. Now move to the third condition. Now move to the third container. And here it is simply written that water and H2 plus O2 is present in this container.
Yeah.
So we will have to check two conditions. First is chemical composition, second is chemical bonding. Now please check chemical composition at first. For
Chemical
water
is 2:2. Water is 2:1.
Chemical composition is 2:1, but this H2 plus O2 chemical composition is 2:2.
Yeah.
Here, my dear, our first condition is not satisfied. Here chemical composition is not uniform.
Yeah.
Okay. Here our first condition is not satisfied. Okay, that means chemical composition is not same everywhere. Now let's move to the chemical bonding. For chemical bonding, you can simply call, sir, for water, 2 atoms of hydrogen is bonded with 1 atom of oxygen, but for H2 plus O2, it is also a mixture. Okay, it is also a mixture because H2 is mixed with O2. So here plus sign is taken. So here plus sign is taken. Plus sign means it is mixing. It is mixed. It is not chemically bonded. Okay. So for water, it is chemically bonded. It is chemically bonded, but for this H2 plus O2, my dear, it is not chemically bonded. Not chemically bonded. It is a mixture. It is a mixture. So here our second condition is also not satisfied. Here first and second, both the conditions are not satisfied.
Don't satisfy it.
So for third container, chemical composition is not same. And also chemical bonding is also not same. So this substance is not a pure substance. Not a pure substance. Okay. Now my dear, this is simply the concept of pure substance. If anybody asks you about pure substance, please tell them any substance is said to be a pure substance if it is homogeneous in chemical composition and also homogeneous in chemical bonding. Both the condition must be satisfied for that substance. Okay. Now, my dear, for your daily life, you simply know that air is a pure substance because the chemical composition and chemical bonding for air should be uniform everywhere. Now, my dear, one more example. You perhaps known about that example. In your bike or your car. Okay, the exhaust gases which are leaving your vehicle, the exhaust gases coming out from the vehicle is a pure substance, okay. Why?
Yep.
Why? Because for the exhaust product, which is coming out from your vehicle, for that exhaust product, the substances are uniformly mixed.
Yeah.
Okay, the substances are uniformly mixed inside the engine. Perhaps you have studied about internal combustion engine or
Yeah.
external
For
combustion engine.
combustion. Yep. Yep.
Okay, in the internal combustion engine, or simply IC engine, in IC engine, the products coming inside your cylinder is homogeneously mixed. Okay, so the substance which is your air or fuel, okay, is homogeneously mixed. So that's why the exhaust product leaving the vehicle is a pure substance, because the substance is uniformly mixed inside the cylinder. So for that exhaust product, the chemical composition and chemical bonding will be uniform everywhere. Okay, so the two example which is very famous for pure substance, first is your air, and second is
Yep.
exhaust product coming out from your vehicle. Okay, so please remember these two examples for pure substance. Okay, now one more example is here. I am writing about the example. One more example is exhaust product coming out from the vehicle. So this is your pure substance concept. I hope this concept is clear to you. Okay,
Yep.
now my dear, now we will move to the next concept here. We will move to the next concept, which is your property of system. This is very important, property of system. You have studied about system. Now please understand about property of a system. Okay, now listen my dear carefully. I have told you about system, that it is a certain quantity of matter upon which our study is focused. Why our study is focused? Because to study the substance present in our system.
Yep.
And a study of substance means we have to find the temperature of substance, the volume of substance, the pressure inside the system, okay, the density of the substance, various parameters we will have to study about. Okay, now my dear, now any system, if any system is given to you, and you are asked to tell the substance present inside the system, to tell about the substance present in the system, then you can simply know about the substance present in the system by various factors. You can simply know the substance present in your system. For
Yep.
example, my dear, you can simply know the substance present in your system, know the substance present here, substance or matter. Okay, you can simply know the substance present in your system by various factors. For example, you can tell about pressure of the substance. You can tell the temperature of the substance. You can tell the density of the substance after studying. You can also tell about volume of the substance. Okay. Now also you know the substance. You may know the substance by taste. By taste. Sometimes you taste the substance and you can easily known about the substance, whatever substance is present in your system. Okay, so taste is also a factor. Taste is also a factor. By the taste, with the help of taste, we can easily know about any substance present in our system. Or taste and color. With the help of color, we can simply analyze the matter or substance present in our system, and etc. Okay. Now my dear, these factors help us to know about any substance present in our system. These all factors are called characteristics of the system. These all factors are called characteristics of the system. Characteristics of system. Please understand what is characteristics of system. Characteristics of system simply means, characteristics of system is simply the factors which tell us about the substance present in our system. Okay, so these all factors are our characteristics of system. Now my dear, here different types of characteristics is written. For example, pressure, temperature, density, volume, taste or color. Here if I ask you, from all these factors, which one is measurable? Which one is measurable quantity? So you can simply tell, sir, pressure is measurable. We can measure pressure. We can measure temperature. We can measure density. We can measure volume. But my dear, we cannot measure taste and color. We cannot measure taste and color. So all characteristics is not measurable quantity. Okay, some characteristics are not measurable. Some characteristics are not measurable. For example, taste or color. Okay, so my dear, all the measurable characteristics which have shown here, all the measurable characteristics is simply called property of system. Here pressure, temperature, density and volume can be measured, and these all are characteristics. So all measurable characteristics are called property of the system. Okay. So here my dear, so here property is simply your pressure, temperature, density and volume. Because these all are measurable characteristics, we can measure these characteristics. So these characteristics are called property. Please see the definition here. All measurable characteristics are known as properties. Okay. Now my dear, now for any system, my dear, please, if I give you two systems, if you are given two systems, let us assume this is room 1. Let us assume this is room 1 and this is room number 2. Room number 2. Okay. And when you studied these two systems, you find you find you will find the pressure of this system here. You will find temperature also. You will find volume. We will find volume. And for this system, for this room number 2, please write here P1, T1, V1. And for this room 2, if you studied the system as room number 2, you can easily measure the pressure of this system, P2, temperature, and the volume. Now my dear, system will only be specified with the values of these properties. Okay, here for both the two systems, these values are not same. These values will not be same, my dear. Okay, so you can simply tell that these properties for the two systems will be different. This means any system is specified by the values of properties. Here pressure is property, temperature is property, volume is property, because these all are measurable. Okay, any characteristics which is measurable is called property. Okay, so with the help of these properties, we may specify our system. Now let's take an example here. Let's take, this is your room, my dear, and at 7 a.m. at 7 a.m. morning, at 7 a.m. you find that the temperature of this room is 20 degrees Celsius. Let us assume in your room at 7 a.m. you find that the temperature of the room is 20 degrees Celsius. But my dear, after some time, let's assume at 3 p.m. At 3 p.m., my dear, system is also same. My dear. But at 3 p.m., the temperature will vary in this system. Let us assume now temperature is 30 degrees Celsius. Temperature will vary with the time. Okay. So this system is same. And we have considered here at 2 point of time. At 7 a.m. the temperature of the system is 20 degrees Celsius, but at 3 p.m. temperature is 30 degrees Celsius. This means that both the properties for this system is different at different point of time, and you can simply tell about condition of your system by temperature. You can simply tell, sir, the temperature is varying here, and for our system at 7 a.m. temperature is 20 degrees Celsius, but at 3 p.m. temperature is 30 degrees Celsius. So temperature is varying here. So by temperature, we are simply specifying the system here. Okay. So properties are that measurable quantity which specify our system. Okay. So this definition is written here. Any measurable quantity which specify the system is called property of system. So this was your basic concept about property. I hope this is clear to you. You simply remember the fact that for any system, we may know the substance or matter present in that system by the following factors, by the different factors. For example, by pressure, temperature, volume, density, by taste or color. So these all factors are called characteristics of system. But all the measurable characteristics, the characteristics which are measurable, is called property. So
Okay.
here pressure, temperature, density and volume is measurable. So we can simply call these factors as property of system. Okay, and various other properties are also present. Okay, various other properties are also present which are measurable. Okay, now let's move to the new concept, my dear. Let's move now. Now now we will start about types of property. What are the types of property? So my dear friend, property is of two types. Property is of simply two types. First one is intensive property. Intensive property. And second is extensive property.
Yeah.
Second is extensive property. Now please understand about these properties, and I will explain these two properties with the help of example. So you will
Okay.
understand easily. So you will understand easily. Now, my dear, what is intensive property? Intensive properties are that property. Intensive properties are that property which are independent of mass or size of the system. Intensive properties are that properties which are independent of size of system. If we vary the size of system, then intensive properties will not get changed. Okay. So please understand this concept. In your room, my dear, please understand, this is very easy. In your room, where you are studying right now, in your room, suppose at this time, my dear, temperature is 15 degrees Celsius. Temperature is 15 degrees Celsius. And the size of system is this. The size of system is, my dear, this. Okay. This is your size of system. And for this size of system, the temperature inside the system is 15 degrees Celsius. Now, if we change the size of system, how? Then we simply put a dividing wall here. Now the size of system is changed. Here, for this part, for one part and two part, you have divided this system in two parts, first part and second part. And these two are system now. Now please understand, can the temperature of first and second part will get changed? No, my dear. If you put a dividing wall here, the temperature of first part will also be 15 degrees Celsius, and temperature of second part is also 15 degrees Celsius. It will not get changed.
Yeah.
So this means temperature does not get affected when we change our size of system. So temperature is our intensive property. Because this is independent of size of system. whether the size of system is large or less, it simply remains constant. Okay, now let's move to the second example of intensive property. My dear friend, in your room where you are studying right now, pressure present is atmospheric pressure. Pressure present is atmospheric pressure, my dear.
Yep.
And when you put a dividing wall here, then in the first part and in the second part, you simply reach in the first part. Suppose you are here in the first part. So in the first part also pressure will be atmospheric pressure. It will not get changed. So pressure will not get changed here. So we can simply call pressure is independent of size of system. So everywhere, my dear, in first part and second